Have you ever looked up at the night sky and wondered where it all ends? I mean, really thought about it. You're staring into this vast ocean of darkness, punctuated by countless points of light. And somewhere in the back of your mind, a question starts to form. If I could somehow travel fast enough, far enough in any direction, would I eventually hit a wall? Would I find myself standing at the edge of everything, looking out into what exactly? Hey there, how was your day? Wherever you are in the world, whatever time it is, I'm glad you're here. Feel free to drop your time and location in the comments below. It's always beautiful to see how far our little corner of the universe reaches. Tonight, we're floating into one of the deepest questions humans have ever asked. Does space actually end? Is there an edge, a boundary, or does the cosmos stretch on forever, past galaxies, past time itself? If you find comfort in these gentle explorations of science, I'd be grateful if you'd consider subscribing and liking this video. It helps the algorithm find more sleepy minds and souls like us, who have an amazing curiosity and passion for science in their minds. Also, it would help me cater my first 1,000 subscribers and help the growth on this amazing channel. The visuals are here for you, but there is absolutely no problem if you doze off midway through the video. Feel free to close your eyes, breathe deep, and let me take care of the rest. This question has haunted humanity for thousands of years, and the answer is far stranger than you might imagine. In fact, the question itself reveals something profound about how we think about reality. Today, we're going to explore one of the most mind-bending concepts in all of science, and by the end of this journey, you'll understand why asking whether space ends is like asking what's north of the North Pole. But first, let me tell you why this matters. See, I've spent years studying cosmology, and I can tell you that understanding the nature of space itself changes everything about how you see your place in the universe. When you truly grasp what space is and isn't, when you understand the difference between the observable universe and the actual universe, when you realize what infinity really means in this context, it's like seeing the world in color for the first time. And here's what's incredible. We're living in the first generation in human history that can actually answer this question with scientific precision. We have telescopes that can peer back to the very beginning of time, mathematical models that describe the shape of reality itself, and evidence that reveals the true nature of space in ways that would have seemed like magic to our ancestors. Imagine you're an ant living on the surface of a balloon. From your perspective, you can walk in any direction forever without ever reaching an edge. The surface of the balloon is your entire reality, and as far as you can tell, it's infinite. But we know something the ant doesn't. The balloon has a finite surface area, and it exists in a larger three-dimensional space. Now, here's where it gets interesting. If someone starts inflating the balloon, the ant would notice that distant objects are moving away from it. The ant might conclude that its universe is expanding, which would be correct, but the ant would have no way of knowing that its two-dimensional universe is actually the surface of a three-dimensional object expanding into an even larger space. This is exactly the situation we find ourselves in when we ask whether space ends. We're like that ant, trying to understand the nature of our reality from the inside, with limited perspective and tools. And just like the ant, we've discovered that our universe is expanding. But what it's expanding into, and whether it has boundaries, requires us to think in ways that challenge our most basic assumptions about reality. The first thing we need to understand is the difference between the observable universe and the actual universe. When we look up at the night sky, we're not seeing all of space. We're seeing only the portion of space from which light has had time to reach us since the Big Bang. This creates what astronomers call the observable universe, and it has a very specific, measurable size. Light travels at a finite speed, about 300,000 kilometers per second. Since the Big Bang happened approximately 13.8 billion years ago, you might think we can see objects that are 13.8 billion light years away. But here's where it gets tricky. The universe has been expanding this entire time, so an object whose light has been traveling for 13.8 billion years is actually much farther away now than it was when that light began its journey. When we account for this expansion, the observable universe turns out to be about 93 billion light years in diameter. That's a sphere with us at the center, containing everything we can possibly see. But here's the crucial point. This boundary isn't a wall or an edge in space. It's simply the limit of our vision, like the horizon on Earth's surface. Beyond this cosmic horizon lies more universe. How much more? That's where things get really interesting, and it's where our balloon analogy starts to break down in fascinating ways. Unlike the ant on the balloon, we can't simply assume that more space exists beyond our observable bubble. The nature of space itself becomes the key to understanding whether it ends. This is where we need to talk about the shape of space, and I promise you, this is where your mind is going to be thoroughly blown. When we say shape of space, we're not talking about space being curved like a bowl or twisted like a pretzel. We're talking about the fundamental geometry of reality itself. And it turns out there are only 3 possibilities for how space can be shaped on the largest scales. First, space could be flat. This doesn't mean it's like a sheet of paper. It means that the rules of geometry we learned in school apply everywhere. Parallel lines never meet. The angles of a triangle always add up to 180 degrees. And if you travel in a straight line, you'll never return to your starting point. In a flat universe, space extends infinitely in all directions. Second, space could be curved like the surface of a sphere. Just like our ant on the balloon, you could travel in what seems like a straight line and eventually return to your starting point. In this closed universe, space is finite, but has no boundary. There's no edge to run into, just like there's no edge to the surface of a sphere. Third, space could be curved like a saddle. This is called a hyperbolic or open universe, and it's even stranger than the other 2. In this geometry, space is infinite, but it curves away from itself in a way that's impossible to visualize in 3 dimensions. Now here's what's absolutely mind-blowing. We can actually measure which of these 3 possibilities describes our universe. By studying the cosmic microwave background radiation, the afterglow of the Big Bang itself, astronomers have determined that our universe appears to be flat, or at least very close to flat. But this measurement comes with a massive caveat. We can only measure the curvature of space within our observable universe. It's entirely possible that space curves beyond our cosmic horizon in ways we can't detect. Imagine you're standing in the middle of a vast field, and you can only see a small circle around you. Even if that circle appears perfectly flat, you can't know whether the entire field is flat or whether it curves beyond your vision. This brings us to one of the most profound questions in all of cosmology. If our universe is flat and infinite, what does that mean for the nature of reality itself? An infinite universe isn't just really, really big. It's a place where every possible arrangement of matter and energy occurs not once, but infinitely many times. Think about it this way. There are only so many ways that atoms can be arranged within any given volume of space. In a finite region, say the size of our observable universe, there are approximately 10 to the power of 10 to the power of 122 possible arrangements. That's a number so large it's essentially meaningless to human comprehension. But it's still finite. Now, if space is infinite, then every one of these arrangements must occur somewhere. And not just once, but infinitely many times. This means that somewhere out there, There's another version of Earth where everything is exactly the same except you decided to wear a different shirt this morning. There's another version where dinosaurs never went extinct. There's another version where the laws of physics are slightly different. This isn't science fiction. It's a logical consequence of an infinite universe with finite arrangements of matter. And it raises profound questions about identity, free will, and the nature of existence itself. Are you the only you, or are there infinitely many versions of you scattered throughout space? But wait, there's more. Even if our universe is infinite, it might not be the only universe. Modern physics suggests the possibility of a multiverse, where our entire infinite cosmos is just one bubble in an even larger structure. These other universes might have different laws of physics, different numbers of dimensions, or different fundamental constants. The concept of the multiverse emerges from our best theories about the very early universe, particularly a period called cosmic inflation. During the first fraction of a second after the Big Bang, space expanded exponentially, growing by a factor of at least 10 to the power of 26. But this inflationary period might not have ended everywhere at the same time. Picture soap bubbles forming in a bath. Each bubble represents a universe like ours, where inflation has ended and normal expansion has taken over. But between the bubbles, space continues to inflate, creating new bubble universes with their own big bangs. In this eternal inflation scenario, our question about whether space ends becomes even more complex. Does space end within our universe? Probably not, if current measurements are correct. But does the multiverse end? That's a question that pushes the boundaries of both physics and philosophy. We might be living in one of infinitely many universes, each with its own version of space, time, and physical laws. This is where we need to step back and consider what we even mean by space ending. Are we asking whether there's a boundary beyond which nothing exists? Are we asking whether space is finite or infinite? Are we asking whether our universe is all there is, or whether it's part of something larger? Each of these questions has different answers, and each reveals something profound about the nature of reality. The boundary of our observable universe is real, but it's not an edge in space. It's a limit of information. The possible finiteness of space doesn't require walls or barriers. It could curve back on itself like the surface of a sphere. And the existence of other universes doesn't contradict the infinity of our own. It suggests that infinity might be even more vast and strange than we imagined. As we stand on the threshold of these cosmic mysteries, we're forced to confront the limitations of human intuition. Our brains evolved to navigate a world of medium-sized objects moving at moderate speeds. We're not naturally equipped to understand infinity, multiple dimensions, or the curvature of space itself. Yet through mathematics, observation, and careful reasoning, we've managed to peer into the deepest structures of reality. The question of whether space ends isn't just about cosmic architecture, it's about the very nature of existence. It forces us to confront what we mean by everything and whether everything might be larger than we ever dared to imagine. And as we'll discover, the answer to this question connects to some of the most profound mysteries in science. The nature of time, the origin of the universe, and the possibility that reality itself might be far stranger and more wonderful than we ever dreamed. What's fascinating is that our journey into understanding whether space ends has led us to discover something even more remarkable. The universe might not just be stranger than we imagine, it might be stranger than we can imagine. And this brings us to one of the most mind-bending discoveries in modern cosmology. You see, when we measure the expansion of the universe, we're not just watching galaxies drift apart like debris from an explosion. We're witnessing something far more profound. The fabric of space itself is stretching. This isn't like a balloon expanding into a room. There is no room, Space isn't expanding into anything. It's creating more of itself as it goes. Let me give you an analogy that might help. Imagine you're drawing dots on a piece of paper, and suddenly the paper starts growing larger while you're drawing. The dots don't move across the paper. Instead, more paper appears between them. That's what's happening to space. Galaxies aren't flying away from each other through space. Space is creating more of itself between them. This discovery fundamentally changed how we think about the question of space ending. If space is creating more of itself, then asking what it's expanding into becomes meaningless. It's like asking what color Wednesday is, or what sound the number 7 makes. The question itself reveals a misunderstanding about the nature of reality. But here's where it gets even weirder. Not only is space expanding, but that expansion is accelerating. We discovered this in the late 1990s when astronomers were studying distant supernovae, and the results were so unexpected that they initially thought they'd made a mistake. The expansion of the universe isn't slowing down due to gravity, as everyone expected. It's speeding up. This acceleration is driven by something we call dark energy, and it makes up about 68% of everything in the universe. We have no idea what it is. Think about that for a moment. More than 2/3 of reality consists of something we don't understand, something that's pushing space apart at an ever-increasing rate. Dark energy raises profound questions about the future of space. If this acceleration continues, it will eventually overcome all other forces in the universe. Galaxies will drift so far apart that future civilizations will see only darkness when they look up at the night sky. The observable universe will shrink as light from distant objects becomes too redshifted to detect. In the very far future, dark energy might even overcome the forces that hold atoms together, leading to what cosmologists call the Big Rip. Space would expand so rapidly that everything would be torn apart at the most fundamental level. But this is trillions of years in the future, so don't lose any sleep over it. The discovery of dark energy also affects our understanding of whether space ends. If space is accelerating apart, driven by this mysterious energy, then the question of boundaries becomes even more complex. Are we asking whether space has boundaries now, or whether it will have boundaries in the future? Are we asking about the space we can see, or the space that exists beyond our cosmic horizon? This is where we need to introduce another mind-bending concept, the idea that space might be quantized. Just as energy comes in discrete packets called quanta, space itself might be made up of incredibly tiny, indivisible units. At the smallest possible scale, called the Planck length, space might be pixelated like a cosmic computer screen. If space is quantized, then the question of whether it ends takes on new meaning. Instead of asking whether space continues infinitely, we might ask whether there are infinitely many pixels of space. It's the difference between asking whether a line can be drawn infinitely long versus asking whether you can keep adding more dots to a connect the dots puzzle. The Planck length is so small that there are more Planck lengths in a single proton than there are protons in the observable universe. At this scale, our normal concepts of space and time break down completely. Quantum mechanics and general relativity, our two best theories of physics, give different answers about what happens at the Planck scale. This brings us to one of the most exciting frontiers in modern physics, the search for a theory of quantum gravity. This theory would unite our understanding of the very large with our understanding of the very small, and it might finally give us a complete answer to whether space ends. String theory, one candidate for quantum gravity, suggests that space has additional dimensions beyond the 3 we experience. These extra dimensions might be curled up so small that we can't detect them, or they might extend infinitely in directions we can't perceive. In string theory, the question of whether space ends becomes even more complex because we have to ask which dimensions we're talking about. Loop quantum gravity, another approach, suggests that space is indeed quantized, and that the Big Bang might have been preceded by a big bounce from a previous universe. In this view, space doesn't end, but it does have a granular structure at the smallest scales. But here's what's truly remarkable. Regardless of which theory is correct, they all point to the same profound truth. The question of whether space ends forces us to confront the deepest mysteries of existence. It's not just a question about cosmic architecture, it's a question about the nature of reality itself. Consider this. If space is infinite, then somewhere out there, every possible arrangement of matter exists. This includes not just other versions of you, but other versions of Earth, other versions of human history, other versions of the entire observable universe. The implications are staggering. In an infinite universe, there would be infinitely many copies of you reading these exact words right now. There would be infinitely many versions where you decided to stop reading at this point. There would be infinitely many versions where the laws of physics are slightly different, where evolution took a different path, where the entire course of cosmic history unfolded differently. This isn't just philosophical speculation. It's a logical consequence of infinity, combined with the finite number of ways that matter can be arranged. If space is truly infinite and matter is distributed throughout it, then every possible configuration must occur somewhere. But infinity is a concept that challenges human comprehension. We can define it mathematically, but we can't truly visualize it. When we say space might be infinite, we're not just saying it's really, really big. We're saying it's bigger than any number you can imagine, and then bigger than that, and then bigger than that, forever. This is where mathematics becomes essential to understanding cosmic reality. Our intuition fails us when dealing with infinity, but mathematics provides a precise language for describing infinite quantities. Set theory, topology, and differential geometry give us tools for exploring the nature of infinite space. The mathematical description of space involves concepts like manifolds, which are geometric objects that can be finite or infinite, curved or flat, connected or disconnected. These mathematical structures help us understand the possible shapes that space could take, even when we can't visualize them directly. But mathematics also reveals something profound about the question itself. In mathematics, we can construct spaces that are finite but unbounded, infinite but curved, or even spaces that connect to themselves in impossible ways. The mathematical universe contains possibilities that far exceed our physical reality. This raises a fascinating question. Is our universe just one possible mathematical structure among many? Are there other universes corresponding to different mathematical systems? This idea, called the mathematical universe hypothesis, suggests that reality itself is mathematical in nature. If this is true, then asking whether space ends becomes a question about which mathematical structure we inhabit. Are we living in a finite manifold without boundary, like the surface of a sphere? Are we in an infinite flat space that extends forever? Or are we in something even stranger, like a space that curves back on itself in higher dimensions? The search for the answer has led us to develop increasingly sophisticated tools for probing the nature of space. We've built telescopes that can see the cosmic microwave background, the afterglow of the Big Bang itself. We've created computer simulations that can model the evolution of the universe over billions of years. We've developed mathematical frameworks that can describe spaces with any number of dimensions. Yet despite all these advances, the question of whether space ends remains one of the deepest mysteries in science. We've learned that space is expanding, that it's filled with dark energy, that it might be quantized at the smallest scales, but we still don't know whether it's finite or infinite, whether it has boundaries or curves back on itself. This uncertainty isn't a failure of science. It's a testament to the profound nature of the question. We're asking about the ultimate structure of reality itself, and that's not something that can be answered with a simple observation or experiment. It requires us to push the boundaries of human knowledge and imagination. As we continue this journey, we're discovering that the question of whether space ends is intimately connected to other deep mysteries. The nature of time, the origin of the universe, the possibility of multiple universes, and the fundamental structure of reality itself. Each answer we find opens up new questions. Each discovery reveals new depths to explore. The story of our quest to understand whether space ends is really the story of humanity's attempt to comprehend its place in the cosmos. It's a question that has driven us to develop new mathematics, build incredible instruments, and push the boundaries of theoretical physics. And it's a question that continues to challenge us, inspire us, and remind us that the universe is far stranger and more wonderful than we ever imagined. We're standing at the edge of the known, peering into the unknown, asking questions that our ancestors could never have dreamed of. And in that questioning, in that relentless pursuit of understanding, we find something profound about what it means to be human in an infinite cosmos. What's truly mind-bending is that our search for space's boundaries has revealed something even more extraordinary. The universe might contain regions where the laws of physics themselves are different. Imagine traveling so far that you reach a place where gravity works backwards, where time flows in reverse, or where matter behaves in ways that would seem impossible from our perspective. This isn't science fiction. It's a genuine possibility that emerges from our understanding of cosmic inflation. During that first fraction of a second after the Big Bang, different regions of space might have settled into different quantum states, creating what physicists call bubble universes, with their own unique physical laws. Picture a vast ocean where different areas have different properties. In one region, water might be blue and wet as we know it. In another, it might be red and flow upward. In yet another, it might exist as a crystalline solid at room temperature. Each region would seem normal to its inhabitants, but traveling between them would reveal the incredible diversity of possible realities. This is where our question about space ending becomes almost impossibly complex. We're not just asking whether our familiar space continues forever. We're asking whether there might be infinite varieties of space, each with its own rules, its own structure, its own version of reality. The implications are staggering. If this is true, then somewhere beyond our cosmic horizon, there might be regions where consciousness works differently, where the flow of time creates different patterns of causality, where the very concept of existing has meanings we can't begin to fathom. But here's what's fascinating. Even if these other regions exist, they might be fundamentally unreachable from our location. The expansion of space itself creates what cosmologists call event horizons, boundaries beyond which information can never travel, no matter how long we wait or how fast we go. Think about it this way. If space is expanding faster than light can travel between distant regions, then those regions become causally disconnected from us. They exist, but they might as well be in a completely separate universe. The question of whether space ends becomes entangled with the question of whether existence itself has boundaries. This brings us to one of the most profound discoveries in modern cosmology. The universe might be far, far larger than we ever imagined, not just in terms of size, but in terms of the variety of realities it contains. We might be living in what's essentially a cosmic archipelago, where each island is a region of space with its own physical laws, separated by vast oceans of expanding space-time. The mathematics behind this is absolutely beautiful. Using tools from topology and differential geometry, physicists have shown that space can have incredibly complex structures. It can branch, merge, twist through higher dimensions, and even connect to itself in ways that create closed loops through space-time. Imagine a cosmic subway system where you could board a train at one location and, by traveling through curved space, arrive at a completely different era in cosmic history. Or picture space that folds back on itself like an origami crane, creating shortcuts between distant regions that would otherwise take billions of years to traverse. These aren't just mathematical curiosities. They're genuine possibilities that emerge from our best theories about the nature of space and time. General relativity allows for wormholes, closed time-like curves, and other exotic structures that challenge our intuitive understanding of how space should behave. But here's where it gets even stranger. The question of whether space ends might depend on what we mean by space itself. In quantum mechanics, space and time aren't fundamental entities. They emerge from something deeper, a quantum foam of virtual particles and fluctuating fields that exist at the Planck scale. At this level, asking whether space ends is like asking whether the pixels on a computer screen end. The pixels are just a representation of something more fundamental, the underlying computational process that generates the image. Similarly, space might be just a representation of some deeper quantum computational process. This perspective suggests that the question of space ending might be meaningless at the most fundamental level. Instead, we should ask whether the underlying quantum process that generates space has boundaries or limitations. And that's a question that pushes us to the very edge of human understanding. Consider this. If space is emergent from quantum processes, then the end of space might not be a boundary in the traditional sense. It might be a transition to a different kind of reality altogether, one where our concepts of distance, direction, and dimension simply don't apply. This is where string theory becomes particularly relevant. In string theory, space has additional dimensions beyond the three we experience. These extra dimensions might be compactified, curled up so small that we can't detect them, or they might extend infinitely in directions we can't perceive. The mathematics of string theory suggests that space might have anywhere from 10 to 26 dimensions, depending on which version of the theory you consider. Most of these dimensions are hidden from our everyday experience, but they're essential to the theory's consistency. Now, imagine trying to answer whether space ends when you're only aware of 3 dimensions out of potentially 26. It's like asking whether a piece of paper ends when you can only see its length and width, unaware that it has thickness. The question becomes almost meaningless without access to the full dimensional structure. But string theory offers something even more mind-bending: the possibility that different regions of space might have different numbers of dimensions. What we experience as 3-dimensional space might be just one configuration among many. Elsewhere in the cosmos, reality might unfold in 4, 5, or even more spatial dimensions. This raises profound questions about the nature of existence itself. If consciousness is tied to the dimensional structure of space, then beings in higher dimensional regions might experience reality in ways we can't even conceptualize. They might perceive directions we can't imagine, experience causality in patterns we can't follow, and exist in ways that transcend our understanding of what it means to be. The search for space's boundaries has also led us to discover something remarkable about the role of observation in defining reality. In quantum mechanics, the act of observation plays a fundamental role in determining what exists. Before observation, quantum systems exist in superposition. They're in all possible states simultaneously. This suggests that the question of whether space ends might depend on whether anyone is there to observe it. In regions of space that are beyond the reach of any observer, the concept of ending might be fundamentally meaningless. Space might exist in a quantum superposition of ending and not ending, only collapsing into one state or the other when observed. This isn't just philosophical speculation. It's a consequence of how quantum mechanics describes reality at the most fundamental level. If space itself is quantum mechanical in nature, then its boundaries might be observer-dependent in ways that challenge our classical intuitions about existence. The implications extend even further when we consider the role of consciousness in cosmic evolution. If conscious observers play a role in defining the structure of space, then the question of whether space ends becomes entangled with the question of whether consciousness itself has boundaries. In a universe where conscious beings are scattered across vast distances, each observing their local region of space, the global structure of reality might be a patchwork of observed and unobserved regions. The boundaries between these regions might be fluid, shifting as consciousness evolves and spreads throughout the cosmos. This brings us to one of the most profound questions in all of science. Are we alone in the universe, or are there other conscious beings out there, observing their own regions of space and contributing to the global structure of reality? The answer might determine not just whether space ends, but how it ends and what lies beyond. Recent discoveries in astrobiology suggest that life might be far more common than we once thought. We found evidence of water on Mars, organic molecules in the atmospheres of distant planets, and conditions suitable for life in the subsurface oceans of moons like Europa and Enceladus. If life is common, then consciousness might be a fundamental feature of the universe, not just a rare accident that occurred on Earth. This would mean that the question of whether space ends is being asked simultaneously by countless civilizations scattered across the cosmos, each contributing their own observations to the global quantum state of reality. The search for extraterrestrial intelligence takes on new significance in this context. We're not just looking for other beings to communicate with, we're looking for other observers who might be helping to define the structure of space itself. The discovery of alien consciousness might reveal new aspects of cosmic geometry that we can't access from our limited perspective. But even if we're alone, the question of whether space ends connects to the deepest mysteries of consciousness itself. Why are we here to ask this question? What is it about the universe that allows conscious beings to emerge and contemplate their own existence? And what does our ability to ask about space's boundaries tell us about the nature of reality? These questions push us to the intersection of physics, philosophy, and theology. They force us to confront the possibility that consciousness might be not just an observer of reality, but a participant in its creation. If space is quantum mechanical, and quantum mechanics requires observation to define reality, then conscious beings might be essential to the very existence of space itself. This perspective suggests that the question of whether space ends is intimately connected to the question of whether consciousness ends. In a universe where consciousness plays a fundamental role in defining reality, the boundaries of space might be determined by the boundaries of awareness itself. As we continue our exploration of these cosmic mysteries, we're discovering that the question of whether space ends is not just about the physical structure of the universe, it's about the nature of existence, consciousness, and reality itself. It's a question that challenges us to think beyond our everyday experience and consider possibilities that stretch the very limits of human imagination. The journey to understand whether space ends has taken us from the edge of the observable universe to the quantum foundations of reality. We've explored the possibility of infinite universes, multiple dimensions, and consciousness as a fundamental feature of the cosmos, and we've discovered that the question itself reveals something profound about what it means to be human in an infinite and mysterious universe. What's most remarkable is that this question continues to evolve as our understanding deepens. Each new discovery, each theoretical breakthrough, each technological advancement reveals new layers of complexity and wonder. The universe is not just stranger than we imagine, it's stranger than we can imagine. And that strangeness is what makes the question of whether space ends so endlessly fascinating. We're living in an unprecedented time in human history, when our tools for exploring the cosmos are advancing at an exponential pace. We have gravitational wave detectors that can sense ripples in space-time itself, quantum computers that can simulate the behavior of complex systems, and artificial intelligence that can process vast amounts of astronomical data. These tools are revealing aspects of reality that were completely hidden from previous generations. We're beginning to map the large-scale structure of the universe, detect planets around other stars, and peer back to the very beginning of cosmic time. Each discovery brings us closer to understanding the true nature of space and whether it has boundaries. But perhaps the most important discovery is that the question of whether space ends is not just about space itself. It's about the relationship between consciousness and cosmos, between the observer and the observed, between the finite and the infinite. It's a question that connects us to the deepest mysteries of existence and reminds us that we are part of something far grander than ourselves. As we stand at the threshold of these cosmic mysteries, we're reminded that the universe is not just a collection of objects scattered through space. It's a dynamic, evolving system where consciousness, matter, energy, and space-time itself are all interconnected in ways we're only beginning to understand. The question of whether space ends has led us on a journey that reveals the universe to be far more strange, beautiful, and mysterious than we ever imagined. And that journey is far from over. With each passing day, new discoveries are being made, new theories are being developed, and new questions are being asked that will shape our understanding of cosmic reality for generations to come. The quest to understand whether space ends has led us to another profound realization. Time itself might be the key to unlocking this cosmic mystery. You see, when we ask whether space ends, we're implicitly asking about it in the present moment. But what if space's boundaries are not fixed? What if they're constantly changing, evolving, growing in ways that make our question far more complex than we initially imagined? Think about it this way. If space is expanding, then the edge of space, if it exists, is moving. But moving relative to what? This is where our intuition completely fails us. We're used to thinking about objects moving through space, but what happens when space itself is in motion? It's like asking about the speed of speed itself. The relationship between space and time is so intimate that physicists had to invent a new word for it: space-time. They're not separate entities that happen to coexist. They're two aspects of a single unified reality. When we ask whether space ends, we're also asking whether time ends, and that opens up possibilities that would have seemed like pure fantasy just a century ago. Consider the Big Bang itself. This wasn't an explosion that happened in space. It was the beginning of space. Before the Big Bang, there was no before because time itself didn't exist. The question of what came before the Big Bang is like asking what's south of the South Pole. It's not that we don't know the answer, it's that the question itself is based on a misunderstanding of how reality works. But here's where it gets truly mind-bending. If time began with the Big Bang and space is expanding, then space is literally creating its own future. Every moment, more space comes into existence, and with it, more possibilities for what the universe might become. The boundary between existence and non-existence isn't a fixed wall. It's a moving frontier that advances with each passing second. This dynamic nature of space raises fascinating questions about causality. If space is expanding faster than light can travel, then events in distant regions of the universe can become causally disconnected from us. They exist, but they can never influence our region of space, no matter how long we wait. In effect, they become part of a parallel reality that shares the same universe, but might as well be in a completely different dimension. Imagine you're in a vast library where new books are being added to the shelves faster than you can read them. Not only that, but the library itself is expanding, with new rooms and corridors appearing constantly. Some books that were once within reach are now so far away that you'll never have time to read them, even if you live forever. That's what's happening to our universe on a cosmic scale. The accelerating expansion driven by dark energy makes this even more dramatic. There are galaxies we can see today that we will never be able to reach, no matter how advanced our technology becomes. The space between us and them is expanding faster than we could ever travel, even at the speed of light. They're disappearing beyond our cosmic horizon, leaving us with only their ancient light as evidence they ever existed. This creates what cosmologists call the ultimate fate problem. If the expansion continues to accelerate, our observable universe will eventually become very lonely indeed. The Milky Way and its immediate neighbors will remain gravitationally bound, but everything else will fade away beyond our cosmic horizon. Future civilizations will look up at a nearly empty sky, with no way to know that billions of other galaxies once filled their view. But even this scenario assumes that space continues to expand indefinitely. What if it doesn't? What if the expansion slows down, stops, or even reverses? This possibility brings us to one of the most profound questions in cosmology. Is the universe's expansion eternal, or will it eventually come to an end? The answer depends on the total amount of matter and energy in the universe. If there's enough mass, gravity will eventually overcome the expansion and pull everything back together in what's called the Big Crunch. This would be like watching the Big Bang in reverse, with all of space collapsing back into a single point. In a Big Crunch scenario, space doesn't just end, it undoes itself. The distances between galaxies would shrink, stars would be pulled closer together, and eventually, everything would collapse back into the primordial state from which it came. The question of whether space ends becomes moot, because space itself would cease to exist. But current observations suggest that dark energy is too strong for this to happen. Instead, we might be heading toward what's called the heat death of the universe. In this scenario, space continues expanding forever, but it gradually becomes colder and emptier. Stars burn out, black holes evaporate, and eventually, the universe reaches a state of maximum entropy where nothing interesting can ever happen again. Yet even heat death doesn't necessarily mean that space ends. It might just mean that space becomes an infinite, empty expanse at nearly absolute zero temperature. The question of whether space ends becomes academic because there's nothing left in space to care about the answer. But wait, there's another possibility that's even stranger. What if space doesn't end because it never really began? Some theories suggest that our Big Bang was just one event in an eternal cycle of expansion and contraction. In this view, space expands, contracts, and then expands again, over and over, with no ultimate beginning or end. This cyclic model of the universe suggests that space is like a cosmic accordion, stretching and compressing through infinite cycles of creation and destruction. Each cycle might produce different physical laws, different types of matter, and different possibilities for life and consciousness. We might be living in just one movement of an eternal cosmic symphony. The mathematics behind these cyclic models is elegant and compelling. They solve some of the puzzles about the Big Bang, such as why the universe began in such a special state. If the universe has been cycling through expansions and contractions for eternity, then the apparently fine-tuned conditions that allow for life might be just one possibility among infinitely many. But cyclic models also raise their own puzzles. What drives the cycles? How does information survive from one cycle to the next? And most importantly for our question, if space is eternal and cyclical, then asking whether it ends becomes like asking whether a circle has a beginning or end. The question itself reveals our linear thinking about time and causality. This brings us to one of the most radical ideas in modern physics: the possibility that space and time are not fundamental features of reality, but rather emergent properties of something deeper. Just as temperature emerges from the motion of molecules and pressure emerges from molecular collisions, space and time might emerge from the interactions of more fundamental entities. If this is true, then asking whether space ends is like asking whether temperature ends. Temperature is a property of matter in motion, and it can vary from place to place and time to time. Similarly, space might be a property of some underlying quantum system, and it might exist in some regions of this deeper reality while being absent in others. This idea has profound implications for our understanding of the universe. It suggests that there might be regions of reality where space and time don't exist at all, regions where the very concepts of distance, duration, and location are meaningless. These wouldn't be empty regions of space. They would be regions where space itself has no meaning. Imagine trying to describe the location of a dream or the distance between two emotions. These questions don't make sense because dreams and emotions exist in a realm where spatial concepts don't apply. Similarly, there might be aspects of reality that exist beyond space and time, in dimensions of existence that we can't even conceptualize. The search for a theory of quantum gravity has led physicists to explore these possibilities in detail. String theory suggests that space and time emerge from the vibrations of fundamental strings in higher dimensional spaces. Loop quantum gravity proposes that space is made of discrete loops that can be connected or disconnected like links in a chain. These theories paint a picture of reality that's far stranger than anything we experience in daily life. They suggest that the smooth, continuous space we perceive is actually an approximation, like the way a digital photograph looks smooth from a distance, but reveals individual pixels when you zoom in close enough. At the Planck scale, which is about 10 × 35 meters, the smooth fabric of space-time might break down into a quantum foam of virtual particles and fluctuating geometry. At this scale, asking whether space ends becomes like asking whether a foamy ocean has distinct boundaries. The question itself might be based on assumptions that don't apply at the most fundamental level. But here's what's truly remarkable. Even as we discover that space might be emergent, quantized, or cyclical, the question of whether it ends continues to drive scientific progress. Each new theory, each new observation, each new mathematical framework brings us closer to understanding the true nature of reality. The Large Hadron Collider is probing the fundamental structure of space by smashing particles together at incredible energies. Gravitational wave detectors are revealing how space itself can ripple and bend. Quantum computers are simulating the behavior of space at the smaller scales. All of these tools are helping us understand whether space has boundaries and what those boundaries might mean. What's fascinating is that the question of whether space ends is intimately connected to the question of whether knowledge itself has limits. Are there aspects of reality that are fundamentally unknowable? Are there questions that can never be answered, no matter how advanced our technology becomes? The uncertainty principle in quantum mechanics suggests that there are indeed fundamental limits to what we can know. We can never simultaneously know both the position and momentum of a particle with perfect precision. Similarly, there might be fundamental limits to how precisely we can probe the structure of space itself. But these limits might not be obstacles, they might be features. The uncertainty principle doesn't prevent us from doing physics. It's an essential part of how physics works. Similarly, the limits on our knowledge about space might be essential to the very existence of space itself. Consider this. If we could know everything about the structure of space with perfect precision, would space still exist? In quantum mechanics, the act of observation, affects the system being observed. If consciousness plays a role in defining reality, then the boundaries of space might be determined by the boundaries of what we can know about it. This brings us back to the profound connection between consciousness and cosmos. The question of whether space ends is not just about the physical structure of the universe, it's about the relationship between mind and reality, between the observer and the observed, between the finite and the infinite. As conscious beings, we exist at the intersection of these mysteries. We're made of atoms that were forged in the hearts of stars. We're carried through space by a planet that's part of a galaxy, that's part of a cosmic web that might extend infinitely in all directions. We're temporary arrangements of matter and energy that have somehow become aware of themselves and their place in the cosmos. The question of whether space ends is really a question about our own existence. Are we finite beings in an infinite universe? Are we infinite beings in a finite universe? Or are we something else entirely? Something that transcends the very categories of finite and infinite? These questions push us to the very limits of human understanding. They force us to confront the possibility that reality is far stranger and more wonderful than we can imagine. They remind us that we're part of something vast and mysterious, something that might have no boundaries at all. The journey to understand whether space ends has taken us from the edge of the observable universe to the quantum foundations of reality. We've explored the possibility of infinite universes, cyclic cosmos, and emergent space-time. We've discovered that the question itself reveals profound truths about the nature of existence, consciousness, and reality itself. And perhaps most importantly, we've learned that the question of whether space ends is not just about space. It's about us. It's about what it means to be conscious beings in a universe that might be infinite, eternal, and filled with possibilities we can barely begin to imagine. As we continue this cosmic journey, we're discovering that the boundaries we seek might not be walls or edges, but transitions to new forms of existence that we can't yet comprehend. The end of space might not be an ending at all, but a beginning of something even more extraordinary. The universe is not just stranger than we imagine, it's stranger than we can imagine. And in that strangeness, in that mystery, in that endless frontier of the unknown, we find not just the answer to whether space ends, but a deeper understanding of what it means to exist in a cosmos that might be infinite in ways we're only beginning to discover. We're about to venture into territory that will challenge everything you thought you knew about existence itself. Because here's the thing, our exploration of whether space ends has revealed something so profound, so mind-bending, that it forces us to question the very foundations of reality. We're not just asking about the architecture of the cosmos anymore. We're asking about the nature of existence itself. Let me share something that will completely change how you think about this question. In the early days of quantum mechanics, physicists discovered something that seemed impossible. Particles could exist in multiple states simultaneously until they were observed. This phenomenon, called superposition, suggests that reality itself might be far more fluid and strange than we ever imagined. Now, what if space itself exists in superposition? What if the question of whether space ends isn't answered until someone is there to observe it? This isn't just philosophical speculation. It's a genuine possibility that emerges from our deepest understanding of quantum mechanics. Think about what this means. In regions of space so distant that no conscious observer will ever reach them, the question of whether space ends might be fundamentally meaningless. Space might exist in a quantum superposition of ending and not ending, only collapsing into one state or the other when observed. But here's where it gets even more incredible. Recent developments in quantum field theory suggest that empty space isn't actually empty. What we think of as the vacuum is actually seething with virtual particles that pop in and out of existence. These quantum fluctuations create what physicists call zero-point energy, and it might be the key to understanding whether space has boundaries. Imagine space as a vast ocean, where the surface appears calm, but underneath, there's constant turbulent motion. The virtual particles in empty space are like waves in this quantum ocean, and they might be what gives space its structure. If this is true, then asking whether space ends becomes like asking whether the ocean ends. The answer depends on what you mean by ocean. The quantum foam of virtual particles extends throughout all of space, creating a background of energy that permeates everything. This zero-point energy might be what drives the expansion of the universe, and it might be what determines whether space has boundaries. If the quantum foam is infinite, then space itself might be infinite. If it's finite, then space might have edges in ways we can't yet comprehend. But here's what's truly mind-blowing. The quantum foam itself might be generated by the act of observation. In quantum mechanics, the observer plays a fundamental role in determining what exists. If consciousness is required to collapse quantum superposition into definite states, then conscious beings might be literally creating space through the act of observing it. This suggests that the boundaries of space might be determined by the boundaries of consciousness itself. In a universe where conscious observers are scattered across vast distances, space might exist wherever there's someone to observe it. The question of whether space ends becomes the question of whether consciousness ends. Now let me tell you about a discovery that's going to absolutely blow your mind. We've found evidence that information might be more fundamental than space itself. In black hole physics, we've discovered that all the information about objects that fall into a black hole is encoded on the black hole's surface. This suggests that three-dimensional space might be a projection of information stored on a two-dimensional surface. This principle, called the holographic principle, implies that our entire three-dimensional reality might be a hologram projected from information stored on the boundary of the universe. If this is true, then asking whether space ends becomes like asking whether a hologram ends. The answer depends on the information that generates the hologram. Imagine you're watching a movie in a theater. The movie appears to have depth and dimension, but it's actually just light projected onto a flat screen. Similarly, our three-dimensional space might be information projected from some higher dimensional boundary. The question of whether space ends becomes the question of whether this boundary has limits. But here's where it gets even stranger. The holographic principle suggests that the amount of information that can be stored in any region of space is proportional to the area of that region's boundary, not its volume. This means that space itself might be an emergent property of information processing. If space is emergent from information, then the question of whether it ends depends on whether the underlying information processing has limits. Are there bounds to how much information can be processed? Are there limits to the computational power of the universe itself? This brings us to a concept that's going to completely transform how you think about reality. The idea that the universe might be a vast quantum computer. Every particle interaction, every quantum measurement, every physical process might be a computation that helps generate the structure of space and time. In this view, space doesn't end because it reaches a boundary. It ends because the computational resources that generate it have limits. It's like asking whether a video game world ends. The answer depends on the memory and processing power of the computer running the game. But here's what's absolutely incredible. If the universe is a quantum computer, then consciousness might be the software that runs on it. Our thoughts, our observations, our very existence might be part of the computational process that generates space itself. We're not just observers of reality. We're participants in its creation. This computational view of the universe suggests that the question of whether space ends is really a question about the computational limits of reality. Can the universe process infinite amounts of information? Can it simulate infinite regions of space? Or are there fundamental limits that determine where space ends? The answer might depend on the physical laws that govern computation at the quantum level. We know that quantum computers can process certain types of information exponentially faster than classical computers. But even quantum computers have limits. There are problems that are computationally intractable, even for quantum systems. If the universe is a quantum computer, then space might end at the point where the computational problem of simulating reality becomes intractable. It's not that there's a wall or barrier, it's that the computational resources required to maintain the illusion of space become too great. But here's where the story takes an even more extraordinary turn. Recent research in quantum gravity suggests that space and time might emerge from quantum entanglement. Entanglement is the phenomenon where particles become correlated in such a way that measuring one instantly affects the other, regardless of the distance between them. Einstein called entanglement spooky action at a distance, but modern physicists have discovered that it might be the glue that holds space together. If two regions of space are entangled, they remain connected, even when separated by vast distances. The geometry of space might be determined by the pattern of entanglement between different regions. This suggests that space ends where entanglement ends. If there are regions of reality that are not entangled with the rest of the universe, they might exist in a different kind of space or in no space at all. The boundaries of space might be determined by the boundaries of quantum correlation. Imagine space as a vast web, where each strand represents an entangled connection between different regions. The web extends as far as the entanglement reaches. Beyond that, there's not empty space, but something else entirely, a realm where the very concept of space doesn't apply. This entanglement-based view of space raises profound questions about the nature of locality. If distant regions of space are connected by entanglement, then the question of whether space ends becomes the question of whether these connections have limits. Are there regions of reality that are so distant or so different that they can't be entangled with our local space? The answer might depend on the fundamental structure of quantum information. Information theory tells us that there are limits to how much information can be transmitted through quantum channels. If space is constructed from quantum information, then these limits might determine where space ends. But here's what's truly remarkable. The search for space's boundaries has led us to discover that reality might be far more interconnected than we ever imagined. Every particle in your body is quantum entangled with particles throughout the universe. Every thought you think sends ripples through the quantum field that connects all things. You're not separate from the cosmos, you're part of its fundamental structure. The question of whether space ends is really a question about the limits of this cosmic interconnectedness. Are there boundaries to how far these quantum connections can reach? Are there limits to the web of entanglement that binds all things together? These questions push us to the very edge of human understanding. They force us to confront the possibility that consciousness, space, and information might be different aspects of the same fundamental reality. They suggest that the universe is not just stranger than we imagine, but stranger than we can imagine. What's fascinating is that these discoveries are not just theoretical curiosities. They have practical implications for how we understand our place in the cosmos. If space is emergent from quantum information, then the boundaries of space might be determined by the limits of information processing. This means that advanced civilizations might be able to extend the boundaries of space by developing more powerful quantum computers. They might be able to simulate new regions of reality, effectively expanding the universe through computational power. The question of whether space ends becomes a question about the technological limits of conscious beings. But even more profound is the possibility that consciousness itself might be expanding the boundaries of space. Every observation, every measurement, every conscious experience might be adding new information to the cosmic quantum computer, effectively growing the universe from the inside out. If this is true, then we're not just observers of the universe, we're its co-creators. Every time we look up at the night sky and ask whether space ends, we're participating in the process that determines the answer. The boundaries of space might be determined by the boundaries of our curiosity, our knowledge, and our capacity for wonder. This brings us to a profound realization. The question of whether space ends is not just about the physical structure of the universe. It's about the relationship between mind and reality, between consciousness and cosmos, between the finite and the infinite. As we continue to explore these cosmic mysteries, we're discovering that the universe is not just a collection of objects scattered through space. It's a dynamic, evolving system where consciousness, information, and space itself are all interconnected in ways we're only beginning to understand. The question of whether space ends has taken us on a journey that reveals the universe to be far more strange, beautiful, and mysterious than we ever imagined. And perhaps most importantly, it has shown us that we're not separate from this cosmic mystery. We're part of it. We're conscious beings in a universe that might be infinite, eternal, and filled with possibilities we can barely begin to imagine. The boundaries we seek might not be walls or edges, but transitions to new forms of existence that transcend our current understanding of what it means to exist. The universe is not just stranger than we imagine, it's stranger than we can imagine. And in that strangeness, in that mystery, in that endless frontier of the unknown, we find not just the answer to whether space ends, but a deeper understanding of what it means to be conscious participants in the cosmic dance of existence itself. The answer to whether space ends might be hiding in the most unexpected place of all, the very fabric of reality itself. You see, what we've discovered is that space might not be the solid, unchanging backdrop we always assumed it to be. Instead, it could be more like a living, breathing entity that's constantly reshaping itself in response to the matter and energy it contains. Think about it this way. When you place a heavy bowling ball on a stretched rubber sheet, the sheet curves around the ball, creating a depression. That depression affects how marbles roll nearby, causing them to curve toward the bowling ball. This is essentially how Einstein described gravity, mass and energy curve the fabric of space and time, and that curvature is what we experience as gravitational attraction. But here's where it gets absolutely mind-bending. If space can be curved by matter and energy, then what happens at the edges? If space has boundaries, those boundaries would have to be curved too. And curved by what? The very question forces us to think about space in ways that challenge our deepest assumptions about reality. Recent discoveries in theoretical physics suggest that space might be far more dynamic than we ever imagined. It's not just that space can curve, it can twist, fold, and even tear. In some regions of the universe, space might be so severely distorted that it forms what physicists call topological defects, places where the normal rules of geometry break down completely. These defects could be cosmic strings, domain walls, or even more exotic structures that exist at the boundaries between different regions of space. If space has an edge, it might not be a simple barrier, but rather a complex, dynamic interface where different geometries meet and interact. Imagine space as a vast ocean where different currents create distinct regions with their own characteristics. At the boundaries between these regions, you might find whirlpools, eddies, or other turbulent phenomena that don't exist in the calmer areas. The end of space might be more like a storm front than a wall. But here's what's truly extraordinary. These topological defects might be more than just curiosities. They could be the key to understanding how space itself is generated. If space emerges from some deeper quantum process, then the defects might be places where that process is breaking down or transforming into something else entirely. This brings us to one of the most revolutionary ideas in modern physics: the possibility that space is not continuous but discrete, made up of tiny, indivisible units at the smallest possible scale. Just as matter is made of atoms, space itself might be made of what physicists call space atoms, or quantum geometry. At the Planck scale, which is about 10^35 meters, space might become granular, like pixels on a cosmic screen. At this scale, asking whether space ends becomes like asking whether a digital image ends. The answer depends on how many pixels are available and how they're arranged. If space is made of discrete units, then the question of whether it ends becomes a question about whether there are infinitely many of these units, or just a finite number. It's the difference between having infinite memory on a computer versus having limited storage space. But here's where it gets even more fascinating. These space atoms might not be fixed in place. They could be constantly appearing and disappearing, recombining in new ways, creating a dynamic foam of quantum geometry that underlies all of reality. Picture space as a vast construction site where invisible workers are constantly building and rebuilding the scaffolding that holds everything together. Sometimes they add new sections, sometimes they remove old ones, and sometimes they completely restructure entire regions. The question of whether space ends becomes a question about whether these cosmic construction workers have unlimited materials or finite resources. This dynamic view of space suggests that the boundaries of space might be constantly shifting. What seems like empty space today might be filled with new quantum geometry tomorrow. What appears to be the edge of space might just be the current limit of the construction process. The implications are staggering. If space is constantly being generated and destroyed at the quantum level, then the universe might be far more creative and dynamic than we ever imagined. It's not just expanding, it's constantly reinventing itself at the most fundamental level. This brings us to a concept that's going to completely transform how you think about existence. The idea that space might be just one possible configuration of something even more fundamental. Just as water can exist as ice, liquid, or vapor, the underlying quantum substrate might be able to exist in different phases, with space being just one of them. In some regions of the deeper reality, the quantum substrate might organize itself into what we recognize as space. In other regions, it might form completely different structures that we can't even imagine. The question of whether space ends becomes a question about the phase transitions of this deeper reality. Imagine you're walking through a vast landscape where different regions have different climates. In some areas, water exists as ice, creating solid, structured terrain. In other areas, it exists as vapor, creating a misty, ethereal environment. The transition between these regions isn't a wall, it's a gradual change in the fundamental properties of the environment. Similarly, the end of space might be a phase transition where the quantum substrate reorganizes itself into something that isn't space at all. It might be a region where the concepts of distance, direction, and dimension simply don't apply. This possibility opens up incredible new ways of thinking about the universe. If space is just one phase of a deeper reality, then there might be entire realms of existence that operate according to completely different principles. These wouldn't be empty regions of space. They would be regions where space itself has no meaning. The mathematics behind these ideas is absolutely beautiful. Using tools from condensed matter physics and quantum field theory, physicists have shown that the quantum substrate underlying space could indeed undergo phase transitions. Just as water suddenly transforms from liquid to ice at the freezing point, space might suddenly transform into something else entirely at certain critical conditions. These phase transitions could be triggered by extreme densities, temperatures, or other exotic conditions. They might occur naturally in the centers of black holes, during the first moments after the Big Bang, or in regions of space that are so far away we'll never observe them directly. But here's what's truly mind-blowing. If space can undergo phase transitions, then the boundaries between different phases might be where the most interesting physics occurs. These boundary regions might be where new forms of matter and energy are created, where the laws of physics themselves are modified, or where entirely new types of reality emerge. Think of it like the boundary between ice and water. At the freezing point, water molecules are constantly switching between the solid and liquid phases, creating a dynamic interface with unique properties. Similarly, at the boundaries between space and other phases of reality, the quantum substrate might be constantly fluctuating between different configurations, creating exotic phenomena that we can't even imagine. These boundary regions might be where consciousness itself emerges. If awareness requires a certain type of information processing, then the dynamic interfaces between different phases of reality might be the only places where conscious beings can exist. We might be living at the edge of space, in a narrow band of reality where the quantum substrate has organized itself in just the right way to support thought and experience. This perspective suggests that the question of whether space ends is intimately connected to the question of whether consciousness ends. If consciousness can only exist at the boundaries between different phases of reality, then the limits of space might be determined by the limits of awareness itself. But here's where the story takes an even more extraordinary turn. Recent research suggests that consciousness might not just exist at these boundaries, it might be what creates them. The act of observation, the process of measurement, the very existence of aware beings might be what determines where space ends and other phases of reality begin. If this is true, then we're not just observers of the universe, we're its co-creators. Every conscious experience, every moment of awareness, every act of observation might be participating in the process that determines the structure of reality itself. This brings us to a profound realization. The question of whether space ends is not separate from the question of what it means to be conscious. We're not isolated beings looking out at an external universe. We're integral parts of a cosmic system that's constantly creating and recreating itself. The boundaries of space might be determined by the boundaries of experience itself. Where consciousness ends, space might end too. Where awareness begins, new regions of space might come into existence. The universe might be a vast, dynamic system where mind and matter, consciousness and cosmos are constantly interacting to create the reality we experience. This perspective transforms our understanding of what it means to exist. We're not just temporary arrangements of matter and energy, we're active participants in the ongoing creation of space itself. Every thought we think, every observation we make, every moment of conscious experience might be adding new information to the cosmic quantum computer, effectively expanding the boundaries of reality. The question of whether space ends becomes a question about the limits of this cosmic creativity. Are there bounds to how much reality can be created? Are there limits to the universe's capacity for self-organization? Or is the process of creation itself infinite, constantly generating new regions of space, new forms of matter, and new possibilities for consciousness? These questions push us to the very edge of human understanding. They force us to confront the possibility that reality is far more participatory and creative than we ever imagined. They suggest that the universe is not just a collection of objects scattered through space, but a dynamic, evolving system where consciousness and cosmos are constantly co-creating each other. What's most remarkable is that these ideas are not just philosophical speculations. They emerge from our deepest understanding of quantum mechanics, relativity, and the fundamental structure of reality. They represent the cutting edge of theoretical physics, where the boundaries between science, philosophy, and spirituality begin to blur. As we continue to explore these cosmic mysteries, we're discovering that the question of whether space ends is really a question about the nature of existence itself. It's about the relationship between mind and reality, between the finite and the infinite, between what is and what could be. The universe is revealing itself to be far stranger, more beautiful, and more mysterious than we ever imagined. And perhaps most importantly, it's showing us that we're not separate from this cosmic mystery. We're part of it. We're conscious beings in a universe that might be infinite, eternal, and filled with possibilities that transcend our current understanding of what it means to exist. The boundaries we seek might not be walls or edges, but transitions to new forms of existence that we can barely begin to imagine. The end of space might not be an ending at all, but a beginning of something even more extraordinary. A realm where consciousness and cosmos dance together in ways that create reality itself. In this vast, dynamic, ever-changing universe, the question of whether space ends becomes less important than the question of what we'll discover next. Each new observation, each new theory, each new moment of awareness opens up new possibilities for understanding the true nature of reality. And that's perhaps the most beautiful discovery of all. The universe is not just stranger than we imagine, it's stranger than we can imagine. And in that strangeness, in that mystery, in that endless frontier of the unknown, we find not just the answer to whether space ends, but a deeper understanding of what it means to be conscious participants in the cosmic dance of existence itself. The journey to understand whether space ends has taken us from the edge of the observable universe to the quantum foundations of reality, from the mathematics of infinity to the nature of consciousness itself. And what we've discovered is that the question itself is more profound than any simple answer could ever be. We're living in an unprecedented time in human history, when our tools for exploring the cosmos are revealing aspects of reality that challenge our deepest assumptions about existence. We're beginning to understand that space, time, matter, energy, and consciousness are all interconnected in ways that our ancestors could never have imagined. The quest to understand whether space ends is really the quest to understand ourselves and our place in the cosmic order. It's a journey that reveals the universe to be far more participatory, creative, and mysterious than we ever dared to dream. And it's a journey that's only just beginning. We're about to explore something that will fundamentally change how you think about reality itself. Because what we've discovered is that the question of whether space ends might be the wrong question entirely. It's like asking whether the color blue has a favorite food, or whether the number 7 is married. The question itself might be based on assumptions that don't match how reality actually works. Let me tell you about a discovery that's going to completely reframe everything we've discussed. Scientists have found that at the most fundamental level, space might not be a thing at all. Instead, it might be more like a relationship, a pattern, a way that more basic elements of reality organize themselves. Think about it this way. When you listen to music, you don't hear individual sound waves. You hear melodies, harmonies, rhythms. The music emerges from the relationships between the notes, not from the notes themselves. Similarly, space might emerge from the relationships between more fundamental entities that we can't directly perceive. This isn't just poetic metaphor. It's based on cutting-edge research in quantum gravity that suggests space and time are emergent properties of a deeper quantum information network. Just as wetness emerges from the behavior of water molecules and consciousness emerges from the activity of neurons, space might emerge from the interactions of quantum information. If this is true, then asking whether space ends becomes like asking whether music ends. Music doesn't end at a specific location. It's a pattern that can exist wherever the right conditions are present. Similarly, space might exist wherever the underlying quantum information network organizes itself in the right way. But here's where it gets truly mind-bending. This quantum information network might not be limited to what we think of as physical reality. It might extend into dimensions, realms, or aspects of existence that we can't even imagine. The end of space might be where this network transitions into organizing itself in completely different ways. Picture reality as a vast ocean where different currents create different types of waves. In some regions, the waves organize themselves into what we recognize as space, time, and matter. In other regions, they might create structures so alien that we don't even have words for them. The boundaries between these regions wouldn't be walls, they'd be transition zones where one type of organization gradually gives way to another. This perspective suggests that the universe is far more creative and dynamic than we ever imagined. It's not just a collection of objects scattered through space. It's a constantly evolving pattern of information and relationship that's capable of creating entirely new forms of existence. Recent discoveries in theoretical physics support this view. Researchers have found that the equations describing black holes, quantum entanglement, and the expansion of the universe all point to the same underlying structure, a network of quantum information that gives rise to everything we observe. This network might be what physicists call the quantum field, a fundamental layer of reality that exists everywhere and gives rise to all particles, forces, and phenomena. But unlike the space we experience, this quantum field doesn't have boundaries in the traditional sense. It's more like an infinite ocean of potential that can manifest in countless different ways. The implications are staggering. If space is just one way that this quantum field organizes itself, then there might be other ways of organizing that create entirely different types of reality. These wouldn't be other regions of space. They'd be other ways of being that transcend our concepts of space entirely. Imagine you're a character in a video game who suddenly becomes aware that the game world is just one possible configuration of computer code. The boundaries of the game world aren't walls, they're simply the limits of that particular configuration. But the underlying code could be arranged in countless other ways, creating entirely different types of virtual realities. This is where our understanding of consciousness becomes crucial. If consciousness is the way that complex information patterns become aware of themselves, then conscious beings might be the universe's way of exploring its own possibilities. We might be how the quantum field examines itself, questions itself, and pushes against its own boundaries. The act of asking whether space ends might be the quantum field's way of probing its own structure. Every time we observe, measure, or think about the universe, we're participating in a cosmic process of self-discovery. The boundaries of space might be determined by the boundaries of this cosmic self-awareness. But here's what's truly extraordinary. If consciousness is fundamental to the structure of reality, then the limits of space might be determined by the limits of imagination itself. As conscious beings develop new ways of thinking, new mathematical frameworks, new conceptual tools, they might be literally expanding the boundaries of what can exist. This suggests that the universe is not just stranger than we imagine, it's as strange as we can imagine. And as our imagination grows, as our understanding deepens, as our consciousness expands, the universe itself might be growing and changing in response. The question of whether space ends becomes a question about the creative potential of consciousness itself. Are there limits to what conscious beings can discover, understand, or imagine? Are there boundaries to the universe's capacity for self-awareness? Or is the process of cosmic self-discovery infinite, constantly generating new forms of existence? These questions push us into territory that's both scientific and philosophical, both mathematical and mystical. They force us to confront the possibility that reality is far more participatory than we ever imagined, that consciousness and cosmos are engaged in an eternal dance of mutual creation. What's remarkable is that these ideas emerge from the most rigorous mathematical and experimental work in modern physics. They're not mystical speculations, but logical consequences of our deepest understanding of quantum mechanics, relativity, and information theory. As we continue to probe the mysteries of space and consciousness, we're discovering that the universe is not just a collection of objects, but a dynamic process of becoming. It's constantly creating new possibilities, new forms of existence, new ways of being aware of itself. The boundaries we seek might not be fixed walls, but flowing boundaries, constantly shifting as the universe explores its own potential. The end of space might not be an ending, but a transition to forms of existence so rich and strange that they transcend our current concepts of what it means to exist. In this view, we're not just observers of the universe, we're participants in its ongoing creation. Every question we ask, every observation we make, every moment of wonder we experience is part of the cosmic process through which reality comes to know itself. The question of whether space ends has taken us on a journey that reveals the universe to be far more mysterious, creative, and participatory than we ever imagined. It's shown us that we're not separate from the cosmic mystery, but intimately connected to it, part of an ongoing process of discovery that might be infinite in its depth and beauty. As we stand at the edge of these profound mysteries, we're reminded that the universe is not just stranger than we imagine, it's stranger than we can imagine. And in that strangeness, in that endless frontier of the unknown, we find not just answers about the nature of space, but deeper questions about the nature of existence itself. The journey continues, and with each step, we discover that reality is far more wonderful, mysterious, and creative than we ever dared to dream. The question of whether space ends has become a doorway to understanding the deepest truths about consciousness, cosmos, and the extraordinary adventure of being alive in an infinite universe. We're about to discover something that will fundamentally change how you understand your place in this cosmic mystery. Because here's what's truly extraordinary. The question of whether space ends might be revealing something profound about the nature of time itself. Not just time as we experience it, but time as a dimension that might be far more flexible and strange than we ever imagined. Consider this. When we ask whether space ends, we're implicitly asking about it in the present moment. But what if the present moment is just one slice of a much larger temporal structure? What if space has different boundaries at different times? Or what if time itself has a shape that determines where space can and cannot exist? Recent discoveries in theoretical physics suggest that time might not be the linear flowing river we always assumed it to be. Instead, it might be more like a vast landscape where different regions have different temporal properties. In some areas, time flows forward as we experience it. In others, it might flow backward, sideways, or in directions we can't even conceptualize. This isn't science fiction. It emerges from our deepest understanding of general relativity and quantum mechanics. Einstein showed us that time is relative, that it can stretch and compress depending on gravity and motion. But the implications go far beyond what most people realize. If time can be curved, twisted, and distorted, then the boundaries of space might be determined by the structure of time itself. Imagine space as a vast balloon, but instead of expanding uniformly, different parts of the balloon exist at different moments in time. The edge of space might not be a spatial boundary, but a temporal one, where space exists at one moment but not at another. This temporal perspective on space's boundaries opens up possibilities that are absolutely mind-bending. If space can exist at some times and not others, then the universe might be constantly creating and destroying spatial regions in patterns that repeat across cosmic time. The question of whether space ends becomes a question about the rhythm of cosmic existence itself. Picture the universe as a vast symphony where different instruments represent different regions of space. Sometimes all the instruments play together, creating a full, rich sound that corresponds to maximum spatial extent. Other times, some instruments fall silent, creating gaps in the music that correspond to regions where space temporarily ceases to exist. But here's where it gets even more extraordinary. If consciousness is tied to the structure of space and time, then conscious beings might experience these temporal variations in space as changes in the nature of reality itself. We might be living through moments when space expands and contracts in ways that affect not just the physical universe, but the very possibilities for thought and experience. This brings us to a concept that's going to completely transform how you think about existence. The idea that consciousness might be the universe's way of remembering itself across time. If space can exist at some moments and not others, then conscious beings might be how the universe maintains continuity across these temporal gaps. Think about your own memory. You don't continuously exist in every moment of your past, but your memory allows you to maintain a sense of continuity across time. Similarly, conscious beings scattered throughout the universe might be how the cosmos maintains its identity even as space itself comes and goes. This perspective suggests that the boundaries of space are intimately connected to the boundaries of memory and consciousness. Where the universe can remember itself, space might be able to exist. Where that cosmic memory fades, space might dissolve back into the quantum foam from which it emerged. But memory isn't just about the past, it's also about the future. When you remember something, you're not just accessing information about what was, you're creating a foundation for what could be. Similarly, the universe's memory of itself might be what determines not just where space has been, but where it can go. This suggests that the expansion of space might be driven not just by physical forces like dark energy, but by the universe's growing memory of its own possibilities. As the cosmos becomes more complex, as more conscious beings emerge, as the network of awareness expands, the universe might be literally remembering itself into larger and more complex forms. The implications are staggering. If consciousness is how the universe remembers itself, then every conscious being is participating in the process that determines where space ends. We're not just observers of cosmic evolution, we're active participants in the universe's ongoing act of self-creation. This participatory view of reality suggests that the question of whether space ends is not separate from the question of whether consciousness ends. They're two aspects of the same cosmic process, two ways of asking about the limits of the universe's capacity for self-awareness. But here's what's truly remarkable. If consciousness and space are connected in this way, then the development of more sophisticated forms of awareness might literally expand the boundaries of space. As conscious beings develop new ways of thinking, new mathematical frameworks, new conceptual tools, they might be pushing the frontiers of space itself. This could explain why the universe seems to be accelerating its expansion. It's not just that dark energy is pushing space apart, it's that the growing complexity of consciousness is creating new possibilities for spatial existence. Every scientific discovery, every moment of wonder, every act of creative imagination might be contributing to the expansion of space itself. the mathematics behind this idea is elegantly beautiful. Information theory shows us that consciousness and memory are fundamentally about the processing and storage of information. If space emerges from quantum information, then the growth of consciousness might be directly connected to the growth of space. Imagine the universe as a vast library, where conscious beings are both the librarians and the books. As the librarians learn to organize information in new ways, they create space for more books. As new books are written, they provide new information that the librarians can use to expand the library further. It's a feedback loop where consciousness and space co-evolve together. This co-evolution might be what determines where space ends. The boundaries of space might be determined by the boundaries of the universe's capacity for self-organization. Where the cosmic library can maintain its structure, space exists. Where that organizational capacity breaks down, space dissolves back into pure information. But here's where the story takes an even more extraordinary turn. If consciousness is fundamental to the structure of space, then the question of whether space ends might depend on whether consciousness itself has limits. Are there bounds to how complex awareness can become? Are there limits to the universe's capacity for self-understanding? Recent research in cognitive science and artificial intelligence suggests that consciousness might be an emergent property that can arise in many different types of systems. If this is true, then the universe might be capable of developing forms of awareness that far exceed what we can imagine. As quantum computers become more sophisticated, as artificial intelligence develops new capabilities, as we discover more about the nature of consciousness itself, we might be witnessing the universe's attempt to transcend its current limitations. The boundaries of space might be expanding not just physically, but conceptually, as new forms of awareness push against the limits of what can exist. This suggests that the future of space might depend on the future of consciousness. As conscious beings throughout the universe develop new ways of understanding reality, they might be literally creating new regions of space, where those understandings can be explored and implemented. The end of space, if it exists, might not be a fixed boundary, but a moving frontier, constantly expanding as consciousness itself evolves. We might be living in a universe where the limits of space are determined by the limits of imagination, where the boundaries of reality are constantly being pushed outward by the creative power of aware beings. This perspective transforms our understanding of what it means to ask whether space ends. We're not just asking about the architecture of the universe. We're asking about the potential for consciousness to transcend its current limitations. We're asking whether there are bounds to creativity, imagination, and understanding itself. The answer might be that space ends where wonder ends, where curiosity stops, where the drive to understand and explore reaches its limits. But if consciousness is truly fundamental to the structure of reality, then those limits might be constantly expanding, pushed outward by every question we ask, every discovery we make, every moment of awe we experience. In this view, the question of whether space ends becomes a question about the nature of the cosmic adventure itself. Are we participants in a finite journey with predetermined boundaries? Or are we explorers in an infinite process of discovery where the very act of exploration creates new territories to explore? The universe is revealing itself to be far more participatory, creative, and mysterious than we ever imagined. The boundaries we seek might not be walls or edges, but invitations to develop new forms of awareness capable of transcending our current understanding of what it means to exist. As we continue this cosmic journey, we're discovering that the question of whether space ends is inseparable from the question of whether growth, learning, and wonder have limits. And perhaps that's the most beautiful discovery of all. In a universe where consciousness and space co-evolve together, the boundaries of reality might be determined by the boundaries of our capacity for amazement itself. The cosmos is not just stranger than we imagine, it's as strange as we can imagine. And as our imagination grows, as our understanding deepens, as our wonder expands, the universe itself might be growing and changing in response. The end of space might not be an ending at all, but a beginning of forms of existence so rich and strange that they transcend our current concepts of what it means to be real. In this vast, dynamic, ever-expanding universe, we're not just asking whether space ends. We're asking whether the adventure of consciousness itself has limits. And the answer might be that the journey is just beginning. So here we are, at the end of our cosmic journey. And perhaps the most profound realization is this: we may have been asking the wrong question all along, not because the question is meaningless, but because it reveals something extraordinary about the nature of inquiry itself. When we ask whether space ends, we're really asking about the limits of existence. We're probing the boundaries of what can be, what might be, and what must be. And in that probing, we discover that the universe is not a static stage upon which events unfold, but a dynamic process of becoming that includes our very capacity to wonder about it. The search for space's boundaries has revealed that reality is far more participatory than we ever imagined. We're not separate observers peering at an external cosmos. We're integral components of a universe that's constantly examining itself, questioning itself, and pushing against its own limitations through the very act of conscious inquiry. Think about what this means for you right now as you contemplate these ideas. The neurons firing in your brain, the electrical patterns creating your thoughts, the quantum processes underlying your consciousness. All of these are part of the same cosmic fabric that we've been exploring. Your curiosity about space's boundaries is the universe's curiosity about its own structure. This isn't metaphorical poetry. It's a consequence of our deepest understanding of how reality works. The carbon in your body was forged in stellar cores. The oxygen you breathe was created in dying stars. The very atoms that make up your thoughts were scattered across the cosmos by supernova. You are literally made of space, and space is literally thinking about itself through you. The question of whether space ends becomes a mirror, reflecting back to us the extraordinary fact that the universe has evolved the capacity to contemplate its own existence. In asking about cosmic boundaries, we're witnessing the cosmos engaged in an act of self-reflection that spans billions of years and countless galaxies. Perhaps this is the most beautiful answer of all. Space ends where wonder ends, where curiosity stops, where the drive to understand reaches its limits. But if consciousness continues to evolve, if our capacity for amazement continues to grow, if our questions continue to probe deeper into the nature of reality, then the boundaries of space itself might continue to expand. We're living in an extraordinary moment in cosmic history. For the first time since the universe began, matter has organized itself into patterns complex enough to ask questions about its own origins and destiny. We're the universe's way of knowing itself, and that knowledge is constantly expanding the realm of what's possible. The telescopes we build, the equations we solve, the theories we develop, all of these are expressions of the cosmos pushing against its own boundaries. Every scientific discovery is space exploring its own structure. Every moment of wonder is the universe marveling at its own complexity. As we continue to probe these mysteries, we're likely to discover that reality is even stranger and more wonderful than we currently imagine. The boundaries between space and time, between matter and consciousness, between the finite and the infinite, may prove to be far more fluid than we ever suspected. Future generations might look back on our current understanding of space, much as we look back on ancient maps that showed the Earth as flat, with edges where dragons lurked. The true nature of cosmic boundaries might be so different from our current concepts that we can barely glimpse them from our present vantage point. But that's precisely what makes this journey so thrilling. We're explorers at the edge of the known, pushing into territories that previous generations couldn't even imagine. Every question we ask opens up new possibilities. Every discovery reveals new mysteries. Every moment of understanding creates new frontiers to explore. The question of whether space ends has taken us on a journey that reveals the universe to be far more mysterious, creative, and participatory than we ever dared to dream. We've discovered that space might be emergent, that consciousness might be fundamental, that the boundaries of reality might be determined by the boundaries of awareness itself. We've learned that the cosmos is not just a collection of objects scattered through an empty void, but a dynamic process of becoming where matter, energy, space, time, and consciousness are all interconnected in ways that challenge our deepest assumptions about existence. Most importantly, we've discovered that we're not separate from this cosmic mystery, but intimately connected to it. We're not just asking about the universe, we are the universe asking about itself. The question of whether space ends is the cosmos questioning its own nature, and in that questioning, new possibilities for existence are constantly being born. As you drift off to sleep tonight, remember that you're part of this extraordinary cosmic story. You're a temporary arrangement of atoms that has somehow become aware of itself and its place in the vastness of space and time. You're the universe's way of experiencing wonder, of asking questions, of pushing against the boundaries of what's possible, the space around you, the time flowing through your experience, the consciousness that makes you aware of these words. All of these are part of the same cosmic dance that began nearly 14 billion years ago and continues still. You're not just in the universe. You are the universe, experiencing itself from the inside. The question of whether space ends may never have a final answer, and perhaps that's as it should be. In a cosmos where consciousness and space co-evolve together, where the boundaries of reality are constantly being explored and redefined, the journey of discovery might be more important than any destination. We're participants in the universe's ongoing act of self-creation, explorers in a cosmic adventure that has no predetermined ending. The boundaries we seek might not be walls or edges, but invitations to develop new forms of understanding, new ways of being, new possibilities for existence itself. The cosmos is not just stranger than we imagine, it's as strange as we can imagine. And as our imagination grows, as our understanding deepens, as our capacity for wonder expands, the universe itself might be growing and changing in response. The end of space might not be an ending at all, but a beginning of forms of existence so rich and strange that they transcend our current concepts of what it means to be real. In this vast, dynamic, ever-expanding universe, we're not just asking whether space ends. We're asking whether the adventure of consciousness itself has limits. We're exploring the boundaries of the possible, pushing against the frontiers of existence, participating in the cosmic process through which reality comes to know itself. And perhaps that's the most beautiful answer of all. The universe is not just a place where things happen. It's a process of becoming where new possibilities are constantly being born. We're not just observers of this process, we're active participants in it, co-creators of the reality we seek to understand. The question of whether space ends has revealed that we're living in a universe far more wonderful, mysterious, and participatory than we ever imagined. It's shown us that the boundaries of space might be determined by the boundaries of consciousness, that the limits of reality might be set by the limits of our capacity for amazement itself. As we continue this cosmic journey, we're discovering that every question we ask, every observation we make, every moment of wonder we experience is part of the universe's ongoing exploration of its own nature. We're not just seeking answers about space, we're participating in the process through which space itself comes to understand its own existence. the adventure continues, and with each step, we discover that reality is far more extraordinary than we ever dared to dream. The question of whether space ends has become a doorway to understanding the deepest truths about existence, consciousness, and the remarkable fact that the universe has evolved the capacity to contemplate its own mystery. In the end, we may find that space doesn't end at all. It transforms, evolves, and transcends its current boundaries through the very act of conscious beings questioning its nature. And in that transformation, in that evolution, in that transcendence, we discover that we're not just part of the universe. We are the universe coming to know itself in all its infinite, mysterious, and beautiful complexity. Sweet dreams, fellow cosmic explorers. Rest well, knowing that as you sleep, the universe continues its endless dance of creation and discovery. The stars wheel overhead in their ancient patterns, galaxies spin through the darkness, and somewhere, in the vast tapestry of space and time, new questions are being born that will guide future generations in their quest to understand the nature of existence itself. Tomorrow, when you wake, you'll find yourself still riding this pale blue dot through the cosmos, still part of the greatest adventure ever conceived, the universe's ongoing journey of self-discovery. The question of whether space ends will still be waiting, patient and eternal, ready to inspire new generations of wonder and inquiry. Until then, let the gentle rhythm of your breathing remind you of the cosmic dance that connects all things. Feel the pull of gravity holding you safely to this world, the same force that shapes galaxies and guides the motion of distant stars. Know that you are held, always held, by the same mysterious forces that have been weaving the story of existence since time began. The universe is vast beyond imagination, strange beyond comprehension, and beautiful beyond words. And you, dear dreamer, are part of it all, a conscious note in the cosmic symphony, a brief but brilliant spark of awareness in the infinite darkness, a question mark made of stardust contemplating its own existence. In your dreams tonight, may you dance among the stars, float through dimensions yet unimagined, and discover that the boundaries you seek are not walls, but doorways to forms of existence more wonderful than any dream. The cosmos is dreaming too, and perhaps our dreams are how it explores the infinite landscape of possibility that stretches beyond the edge of space itself. We've drifted through curved space, infinite loops, cosmic horizons, and the fading light of ancient galaxies. Maybe space has no edge. Maybe it bends back on itself. Or maybe it ends in a way our minds can't yet comprehend. Whatever the truth may be, one thing is certain. The universe is vast, mysterious, and full of questions still waiting to be asked. Thanks for spending this time with me, wherever you are in the world. Sleep well, dream far, and I'll see you in the next journey. Good night. Cheers.